the computing vision field. And there's a professor at Stanford called Andrew Ng, who works at Baidu now. And then I think in 2014, his system was able to recognize cat from pictures better than human could. And by just watching YouTube videos. And the program doesn't even know what a cat is. So it was purely by watching millions of cat videos and non-cat videos on YouTube, and was able to outperform humans in essentially image processing. Yes?
So it was trained with positive and negative?
Yeah, it was trained with positive and negative. And the training method, by the way, with these multi-layered neural network is a method called back propagation. It's essentially a regression where you have it's a kind of a supervised learning, meaning you have a lot of training data with inputs and output. You know, for cat, you have a lot of pictures and you have yes, no answers, and you feed all those data into this neural net, and all the weights adjust themselves and to have the least deviation from the training answers. And then after you train the system, and then you feed into the actual images, and it can give you the output, whether it's yes or no. Yes?
How many examples did you do training with that?
Millions. So essentially, a big trick of designing these networks is how many parameters are there in this system. And the more parameters you have, the more data you have, because you need. Because if you don't have enough data, then you cannot fit. You cannot have train the system. If you have too much data and not enough parameters, you have another problem. But usually with such a system, it has a lot of parameters, so you need a lot of data. So a lot of the optimization is actually how do you have a system with not too much complexity, so that it doesn't require too much data that allow you to do it. And in fact, one big reason that neural net didn't take off until 2012 was because the availability of data and the associated computing power that's required to train the system.
Well, we've had the internet for way before 2012. So what's special about the internet in 2012?
I think part of it is perhaps the computing power. You know, Andrew Ng actually went from Stanford to join Google, and he was the founder of Google Brain. And they built a huge 16,000 node cluster in order to build a big system. And then the GPU was discovered to be a good fit for these type of computation, because it requires a lot of matrix multiplication, and GPU were very good at it. And so that became a booster, accelerator to the system for this as well. And you know, I am actually not an expert in the field. Everything I said, I read on the plane. Actually, I started a little earlier than that. But for the details, probably I don't know. For some reason, the big breakthrough didn't happen until 2012. And since 2012, in the last 5 years, the wave has been huge.
The internet was important in training Watson, so even before 2012, the internet.
Well,
there's also been improvements in the training techniques.
Right.
There were some substantial ones that kind of made it possible to go from one hidden layer to two hidden layers.
Right. In fact, it's quite fascinating if you go into the archives for this contest. And every year, there's another company who have more layers. Right. And Google has a 23 layer. And then Microsoft has 155 layers. so everybody tried to outclass the other company by building bigger network. But it was all based on the same principle. And before this, AI was a very rich field. It has much more complex algorithms and much more deeper math than just a simple gate with input and output. But in a number of fields, a simple model like this has proven to outperform many of these much more complex algorithms. And the simplicity of this system is also a advantage. Now the disadvantage is the amount of data that it needs for the system to perform. So this is a convolutional neural network. Now there is another neural network that is becoming more and more popular in the last few years. Convolutional neural network is very good in computer vision, in classification of objects within pictures. And it's always feed forward. So all the arrows go forward. And so it's actually simple when all the arrows go one direction and you can just train the system. Now, this is called RNN, recurrent neural network. It starts to introduce arrows going backward. And with this network, it becomes more complex. Because that means one way of thinking about this is it basically multiplies itself. It becomes a network that feeds into another network, feeding to another network. And one property when you have arrows going backward is this system starts to have memory. So when you recognize pictures, you don't need to have memory. You just feed into something and it gives you the answer whether it has a cat or not. But when you need to translate, for example, from English to Chinese, then you need to have memory. The last word actually matters for the next word. So for a field like translation, like natural language processing, this network becomes a breakthrough model. And over I think it's in February of 2016, Google Translate threw away 10 years of work by over 100 engineers. Everything threw away. Just entirely replaced by an 8-layer RNN system, end-to-end. And that outperformed the system they built in the last 10 years. So that would be an example, the power of neural net, how it transformed translation as well as speech recognition. Sorry, yeah.
I was just curious, even though this has a different connectivity connection,
Yes.
you still use the same back propagation algorithm to train it?
I am not sure,
Yes.
but I think we do. Yes.
Yes, we can enroll. We can easily enroll.
Yeah. Essentially, you can roll them out, and one popular recurrent network is LSTM, long short-term memory, and that is the one that's used for the translation. Essentially, they become one word. It's like one network feeding to another, and similarly, speech recognition now is entirely taken over by neural net. The previous method of speech now are entirely outperformed by this new model. So another big event, as all of you probably know, was also happened last year. Was AlphaGo. It actually has a hybrid algorithm within the AlphaGo system, and that for the first time it beat a world champion in Go, and that wasn't thought to happen this soon. People think it's going to be another 10 years before a computer can beat a human player because of the complexity of the game. But that happened last year, and I think it'll be hard for this computer to lose again.
So this is also the feedback loop, this recurrent?
Now, this has a more complex system. Some of people here might know it better. It has a policy network, has a value network. It tries. So with this, because it's a game, so you need to have a reinforcement learning thing where you don't have the answer. But you kind of always try to predict. You try to learn how to play a game better by keep playing with yourself, and then it has because the complexity is too big. You have to have smart ways to cut down the complexity by narrow down the problem space. So I certainly haven't read the details of this system, but it has neural net, as well as some Monte Carlo algorithm inside of the AlphaGo, and combine various methods to achieve the desired outcome. Anyone here knows more about?
A summary would be that since it's got this control element, it makes it different than, say, linear regression, where you're trying to do what's called function approximation. You've also got to design the controller. And so the way the neural nets get used is with a Bellman equation, and the neural nets are approximating the value function of the Bellman equation, and use that to calculate the actions that you're going to take as you go along. You have to kind of iterate back and forth between adjusting the actions and doing a better job of estimating the Bellman equation.
Right. Now, the creator of AlphaGo is a company called DeepMind, which was acquired by Google, and they had published some pretty detailed descriptions of how AlphaGo is designed. Now, it certainly have an impact that if computer could beat human in Go, what else can it do, or what can it do? So that really sparked a lot of discussion over the last year about AI, both the opportunities and the risks. So I'm gonna switch gear a little bit as we start thinking about the opportunities and the risks. And this is the sort of the area I got myself familiar with over the last year as I joined an internet company. So if we look back 20 years at the internet, that was certainly a revolutionary technology. Now the technology itself might not be so advanced. It's not like a big scientific breakthrough. You know, all the fundamental technologies was created years ago. But it was just a whole, everything came together to allow it to start connecting the world and connecting everyone together. And for a person 20 years ago, or for a company 20 years ago, that they all see internet was happening, but the first reaction could be, okay, what does it mean? It means I can have my web page, or I have my personal web page, or my company has my company web page, and now if I'm a newspaper, it affects me a little bit more, so maybe I should create a more advanced website to publish my information. So every company start to hire a couple HTML programmer and thinking that's it. But 20 years, over the course of 20 years, we know the impact of internet went far beyond that. Just because of the simple connection, it was able to disrupt and reshape one industry after another. And in a short 20 years, almost no industry was immune to the effect of the internet. Starting from the media, then it certainly changed how we buy stuff, all the e-commerce that's happening online. And then all the information organization certainly completely changed. I no longer need to go to a library to do any research. And then social networking happened, and that dominated our lives.
Let me stick in something here.
Yes.
Let me give you a 60-year perspective. Well, going way back, 51 years ago, I created the Stanford Artificial Intelligence Lab, nominally working for John McCarthy, who had introduced the term artificial intelligence. Big mistake, in my view, and we should get rid of it now.
Too late.
No, it isn't too late. It's a bunch of bunk. There's nothing artificial about what you were doing. It was based on the egocentric view that humans were the top of the notch on intelligence, which is total bunk. I believe I can prove that we are the stupidest species that has ever walked the earth. But that's another topic.
Just show them on cat
Well, back in when we started the AI lab, we all scoffed at perceptrons And of course, they were clearly silly. But they've come a long way. And it's not artificial, it's a bunch of really good engineering, I would say. One thing that people don't seem to talk about, the internet, where did that come from? It was a result of open source development. No patents, freely sharing. If that had not happened, the internet would not have happened. Now we're going back into this mode of patenting everything and not sharing, and that inhibits progress. You mentioned social networks. I invented the first one. That was in the early 70s, called Finger.
Figure.
So
But-
you also enabled the first internet worm.
What's that?
You also enabled the first internet worm.
Yes, not me. What happened was UC Berkeley put their version of Finger into Unix, and it was vulnerable. The version that I made ran on a DEC 10 and DEC 20, and it never got nailed. Anyway, off topic, but and things are changing fast.
Certainly, certainly. And in fact, sometimes I hope we are more stupid. Because, sometimes I think we are too smart for our own good. So the faster we develop, it might be a faster race to the end. But, and I think I read some maybe biology books. In fact, the simpler or the more stupid the organism, the longer it survives.
Oh, yeah.
Anyways.
Yeah.
Okay, all right. So back to the internet. So as we know, it changed a lot of industries. It changed e-commerce. It changed our lives. It changed enterprise as well, where I worked in. We talked about cloud computing. What's cloud computing? It's really learned from internet data centers, how internet data centers serve the consumers. Now we are just trying to translate that into the how we serve the enterprise customers. And when we talk about big data, that's also really enabled by the internet. And now we're talking about Internet of Things, as how the different devices can be connected, and there are certainly more devices than humans. So it poses another interesting change that the internet can bring. So internet certainly changed everything. So the questions is, without thinking more deeply about the fate of humans in the face of AI, now with the technology that's happening, inside of Cheetah Mobile, which is a company I worked in, and inside of many other companies, really, we are thinking what industries this would change, and in what sequence that AI will change. Yes.
One important change of what Les was talking about was the end of Japan's attempt to dominate the computer industry. And I was at the Scuba conference in 1985
Yes.
Researching how this would impact IBM, because at that time I was in market research.
Yeah, they were called fifth generation or something.
Fifth generation computer.
Fifth generation computers.
The biggest, financed by the government conference I've ever seen.
Right.
And people from all over the world, and it just, the variety of things of the whole computer industry was coming to bear. But it was the end, because the management of Fujitsu and Ricoh and all the companies is, no longer can our very best people be put on this. We have to go back and make money.
Right. So the entire AI field I read has gone through cycles.
Yes.
It has a period of great activities, followed by the winters. And the 80s was a very active period, and the 90s, in fact, the neural network became, or even the entire AI become quite a neglected term, or even a dirty word. I heard that you're still working on neural networks. But in the last 5 years, it's certainly become a period of activity. So the question is whether it's going to go into winter again, or this time it actually has an impact to the various industries. Right? So, and we are of the opinion, the people I work with, in our company and the companies close to us, we actually think this time it will have a pretty profound impact to industries. And the main reason, again, go back to my disclaimer, this is a relatively very shallow talk. So we are staying at pretty shallow level. So at the most shallow level, how deep learning is different from the algorithm before. How it's different is one way of looking at how computer or how computing infrastructure is being used. There are kind of three elements. There is the algorithm, which often is at the center of everything. And then there's the data that are being processed or being generated by the algorithm. And then there is a whole infrastructure. We can call it a computing infrastructure that is supporting the algorithm. And in the balance between these three bubbles, we are of the opinion that algorithms are becoming less important in more and more fields. In fact, yeah, and the data and the computing infrastructure are becoming more important in those fields, and that changed the game a little bit. So the data and the computing power become the new differentiators. So for a new company like ours or like many others, it became an opportunity to, this is a new word I learned, band overtaking. I think this is in the car racing when you can pass another car while you are making a turn. It's harder to making a pass on a straight line. So this is when the world is taking a little turn. And it's easier for the order between the companies to be changed. For one thing, there are those companies with a lot of smart algorithm people, and now their advantage might dissipate, especially if they work in certain fields. For example, at Google,